In lab 4, we are going to be taking a pile of data from a series of reactions where someone studied the rates of the reaction of an iodine clock reaction. And so in the lab, we'll be processing the data and analyzing it and drawing conclusions. Normally, we would get to actually do this experiment in the lab. And so I wanted to show you what it looks like first and talk through the chemical reaction that takes place. So first, I'm going to just show it. The cool thing about the iodine clock reaction is you mix together a whole bunch of clear liquids and you watch it and it stirs for a while and it's just clear and it's clear and it's clear. And then suddenly, it starts to produce enough iodine, which is just any amount, that will react with a little bit of starch that's in the solution, and it will turn this bright blue. And sometimes it's more of a brown blue, but hopefully it's this nice bright indigo blue. And so here's the reaction. We've combined everything together, and depending on the concentrations and the temperature, it'll take some time to turn dark, dark, dark blue or, black blue. And that's our iodine clock reaction. And I think they'll show it again here. Yeah. And that's at a different concentration. And so the reaction that's taking place is between iodide right here and S2O8 2 minus, another anion. When we bring these two together, they're going to form sulfate ions and iodine, which is molecular iodine. It's two iodine atoms covalently bonded together. Now, this reaction happens really fast, actually. What step in blue is the slow step, but it's still a fast reaction, to the point that if you were going to time it with a stopwatch, I wouldn't trust myself to do it perfectly, especially with the amount of human error between seeing something and hitting a button. But this reaction has a really clever trick that we can employ to calculate the initial rate of the reaction when it first starts taking place. So first, there's a few tricks, actually. The first trick is that we include starch in the reaction mixture. Iodine plus starch turns this bright blue. Spelled that wrong, sorry. And it's that blue color that we use as a visual cue that we've produced iodine. So once the iodine is created, it reacts with the starch and the solution turns blue. So this means when we combined everything together, we would instantly see blue. And that's not going to help us compare concentration to like an amount of time and develop a rate from that, just visually with simple tools like a stopwatch. So this is when we employ the second trick. We add another chemical to the reaction mixture, one that does what we call a side reaction, and that is this S2O3 2 minus. This will react with iodine very fast, like super duper fast, such that the iodine will react with the S2O3 before it reacts with the starch. So it's fast compared to our starch reaction that turns it blue. Okay, so we can put in a chemical that'll react with any iodine that's created and essentially stall our reaction with starch. And so we put a very specific amount of S2O3. So we put a known amount. And in our lab, we put in we make sure there's a concentration of 0.2 molar. Now this is a 1-to-2 ratio with the iodine. So that means if we have this reaction take place, it'll react, all the iodine that's produced will quickly react with the S2O3 until there is no more S2O3 left. And at that point, all we'll have left is it produces I minus, which just feeds itself back into this reaction up at the top that we're interested in, and it'll react with any S2O8 around. So after it reacts with all of our S2O3, then we'll finally start producing iodine that can react with our starch. And so that means when we see the blue color, when we see that dark blue color, we know that the concentration of iodine that we've produced in that amount of time is equal to 1/2 of the concentration of the S2O3 that we added to our reaction mixture. So that means we have this idea at the exact amount of time that it goes blue, like however from start to turning blue, that amount of time is exactly the amount of time it takes to produce 0.100 molarity of iodine. And so we can take the concentration and time at the beginning of the reaction and develop a initial rate from that information for the very beginning of it. And so that's the way we're going to calculate rates in this lab. And those reaction rates are going to be used to determine the overall order, because we'll do this reaction in a number of different ways. We'll vary the concentration of both of our reactants. And by doing that, we'll see a different rate each time. And we'll be able to look at the dependence between initial concentration and rate, which allows us to derive the order with respect to that reactant. And so we'll be doing the style of problem solving that we saw in the lectures to determine the order of iodine and the order with respect to S2O8 -2, the anion, to build a rate law. And then we can take that rate information and that order information and calculate rate constants from that as well. And that's how we're going to build a rate law for the iodine clock reaction. That is a lot of fun to do because it's always surprising when it turns blue. And hopefully we'll be able to do it someday if we ever come back to in-person learning.